In practical terms, it's very common to have tables with many-to-many relationships. For example, a single customer may buy many items, and a single item may be purchased by many customers. This is often implemented with a junction table. Here's a simple and practical example. We're using the test.db database for this example. And let's start by just looking at the table structures in the test database. So here's the three tables in this database. There's customers, there's items, and there's sales. And you notice that each of these tables has an ID column. The ID column identifies a specific row in each table. The sale table performs the role of a junction table. Its item ID and customer ID columns allow the other two tables to have a many-to-many relationship. That is, a customer may be related to many items, and an item may be related to many customers. A junction table is a common way to accomplish this. Junction tables are common in the database world, sometimes linking many tables, and sometimes performing many separate roles. Let's take a look at an example of a query that uses this junction table. So we're selecting from the customer table the name column as customer, and from the item table the name column as item, and from the sale table the price column as price. Our from clause uses the customer table, so that would be analogous with the left table in the join. But we're actually going to have two joins. We're first going to join the sale table, and we'll join it on the intersection of the customer ID column in the sale table and the ID column in the customer table. And so the condition is that these two columns must be equal. And our other join clause joins the item table as I, and this joins it on the condition of the item ID column from the sale table being equal to the ID column in the item table. And we're going to order this by customer and item within customer. So there's our joined query, and you see the sale table is being used as the junction table here. So I'm going to press go, and there's our result. So customer Bill Smith bought this item box of 64 pixels for $29.95. Bob Smith bought a barcode for $9.99, and Mary Smith actually bought three items. She bought two box of 64 pixels for $29.95 each, and one sense of humor for $19.95. So that's a result from three different tables effectively, because the price column is actually in the junction table. And it allows this many-to-many relationship. Mary Smith is related to two different items, one of them twice, and this box of 64 pixels is related to two different customers. Now, you might want to have a report that also includes customers without sales, and you can use a left outer join for this. First, we're going to add a customer with no sales, and I'm going to put that up here above our select statement. And then I'm going to change our joins to left joins. So both of these have to be left joins, because both of them are using the junction table. And when I press go, you see we now have this additional row with Jane Smith that has not bought any items at any price. So our left outer join includes all the rows where the condition is met, plus any rows in the left table. And remember, our left table is the one in the from clause, customer, even though that row does not have any corresponding rows in the right-hand tables. So now I'm going to restore the database to its original state by deleting that additional customer. First, find out its ID. And its ID is number 4, so I'm going to delete from customer where ID equals 4. And one row affected, so our database is now restored to its original state. Many-to-many relationships are common in relational database applications, and the junction table is a very common tool for managing these relationships.